Welcome, geometry students, to the homework help video, page 465. Let's go ahead and get started with these problems. Numbers 1 and 2 are true or false. Okay, let's take a look at these. If you are given the lengths of any two sides of a right triangle, you can solve the triangle. Excuse me. Well, what you were taught in class is you need to be given at least two parts. And at least one of those needs to be a side. So, were you given at least two parts? Yes, you were. Was at least one of those parts a side? Yes. So that's true, definitely. Listen, students, anytime you're given two parts of a right triangle, not including the right angle, of course, anytime you're given two parts to a right triangle, and one of those parts is a side, then you're good, okay? Alright, number 2. If you are given the measure of one of the acute angles of a right triangle, you can solve the triangle. Well, first of all, you need how many parts? 2, not including the right angle. So, did they give you two parts? No, they gave you one. So right away it's false. However, let's pretend for a second that they gave you two acute angles. Could you still solve it? No, because you need at least one side. So false. You cannot solve that triangle. Okay? Alright, I hope that makes sense. Let's continue on. Numbers 3 through 6, the directions say to use a calculator to approximate the measure of the acute angle. Round to one decimal place. So, here we go. Here you're looking for an angle. Please don't miss this, students. You're missing the angle, tangent of an angle. So this is when you use your inverse tangent button. So you would hit tangent to the -1, wherever that is on your calculator, and then 1.6. Now, let me pause and say this. Make sure that you're in degrees, okay? If you're not in degrees, you're not going to get the right answers out, okay? Alright, so I've hit inverse tangent on my calculator, 1.6, enter, and I'm getting 57.99 degrees. They want us to round to one decimal place, so 58.0 would be one decimal place. Alright, okay, number 4. Notice we're missing an angle again, okay? We're missing an angle, and so we're going to hit tangent, inverse tangent, or tangent to the -1 of 4.8. Listen, students, the only time you use inverse tangent or inverse cosine or inverse sine is when you're missing the angle. You're looking for an angle. I'm amazed every year how students don't get that when I teach this. Sorry guys, I've really got a little bit of a cough today. But listen guys, you only use these inverse function buttons when you're looking for an angle or when you're missing an angle. I can't make it any simpler than that, okay? If you type this into your calculator right here, inverse tangent of 4.8, you will get 78.2 if you round correctly. Alright, moving on to number 5. Okay, ask yourself, am I looking for an angle? Am I missing an angle? The answer is yes. So you hit inverse sine of 0.7, okay? And if you type that in correctly, you will get 44.4 degrees if you round correctly. Number 6, are you missing an angle? Yes, you are. So you're going to hit inverse cosine of 0.7 or 0.7. If you hit enter on that, and if you round correctly to one decimal place, you will get 45.6 degrees. Okay, 45.6. So numbers 3 through 6 were nothing more than calculator problems, okay? Just knowing how to type those in. Alright, let's continue on. Number 7. Okay, 7 through 10, the directions say to find the measure of the indicated part. So for number 7, we're looking for the length of QS, okay? Now, I want to show you something, guys. Let's really just walk through this and just take our time here. First of all, I know for sure that I have a what? A quadrilateral, okay? Okay, piece of cake, 4 sides. Number 2, students, I have 2 parallel lines cut by a transversal. Got it. So consecutive interior angles are supplementary. So if this is 90, this is 90. Well, this angle here and this angle here are both consecutive interior angles. So if this angle is 90, this angle is 90. So the first thing that I wanted to show you is you have a rectangle. Okay, alright, now that I've showed you that, let's continue on. Let's find the length of QS. I'm going to copy the bottom triangle. I have a right angle here, I have a length of 4 here, and I have degrees right here, 25 degrees. Now, I'm going to put X right here. Got it? Now I have some questions for you. First of all, do I know at least 2 sides of the triangle? No, I do not. If I did, I could use Pythagorean's theorem, but I can't. Number 2, and by the way, remember, Pythagorean's theorem only works on a right triangle. Okay, moving on. Number 2. Is it one of my special triangles? No, it is not 30, 60, 90. It is not 45, 45, 90. So the only thing left for me to do is use trig functions. So circle the angle you're going to use. Go straight across. This is my opposite side. Go straight across from the right angle. This is my hypotenuse. So this side here is my adjacent. So I have a question for you students. I know this side, and I'm looking for this side. So my question is would not that be the 2 sides I want to use? Sure it is. Think about it. Why would I use opposite? There's no need to. That's just another unknown. We'll call it Y. I have no idea what it is. I want to use one side that I know and one side that I'm looking for. Now, could you solve for Y using a trig function and then use Pythagorean's theorem to find X? Sure. That's going to take twice as long. There's no need to do that, okay? Alright, so my 2 sides here are hypotenuse and adjacent. Now, which trig function has hypotenuse and adjacent? Let's see. SOHCAHTOA. Looks like cosine is. Cosine is adjacent and hypotenuse, and those are my 2 sides. So I'm going to write the cosine of 25 degrees equals adjacent over hypotenuse. Now, first of all, the cosine of 25 is nothing more than a decimal, and it's point. If you use your calculator, you'll see. Oh, by the way, when you type this in, are you looking for a degree or an angle? No, you are given the angle right here. Okay, so you would use your regular cosine button. You would hit cosine, not cosine inverse. Cosine, and then 25 degrees. And if you type that in correctly, you would get 0.9063. Now, to get rid of my fraction, my denominator is x. I'm going to multiply both sides by x. So 0.9063x equals 4. If I multiply this side over here by x, my x's cancel, leaving me with 4. Now next I'm going to divide both sides by 0.9063. And if you do that correctly, you're going to get 4.4. 4.4. Alright, moving on to 4.41. Did they say it around the 2 decimal places? No, they did not, but 4.4 is acceptable. Alright, number 8, we're looking for QT. Now, remember students, we just found this length here to be 4.4. So for me, guys, I'm using Pythagorean's theorem. That's just me, okay? Look at my right triangle here. You say, Mr. Earhart, can you do that? How do you know that QS in this problem is 4.4? Because the triangle hasn't changed, guys. It's the exact same triangle. So QS is still 4.4. So I'm going to use Pythagorean's theorem. I have one leg squared. My other leg, I don't know. We'll call it x. That's what I'm looking for. The length of QT right here. I'm going to call that x. So x squared equals hypotenuse squared, 4.4 squared. So 16 plus x squared equals 19.36. Now we're trying to get x by itself, so bring the 16 over and make it a negative 16. And we're left with x squared equals 3.36. Okay, now let's take the square root of that. And we're going to get 1.833. So I'm just going to call it 1.8. Alright, 1.8. And the answer is 1.87. Close enough, okay? Alright, continuing on to number 9. They want us to find the angle of TQS. Well, students, come on, look. Here's T, Q, S. So from T to Q to S, we're looking for this angle right here. Okay? So that's really pretty easy. We have a triangle right here. Right here we have 90 degrees. So 90 plus 25 is 115. So this angle right here has to be 65 degrees. Because 115 plus 65 gives you 180. And all triangles have interior angles that add up to 180. Alright, moving on to number 10. They want us to find the length of RS. Now let's go back 2 problems. We found the length of QT right here. It's 1.8. Remember at the very start of this problem, I showed you we have a rectangle. Well, rectangles have congruent opposite sides because rectangles are parallelograms. So if QT is 1.8, then RS is also going to be 1.8. Alright? So, or 1.87 according to their answers. But 1.8 is also acceptable. Okay, alright, moving on to numbers 11 through 18. Use a calculator to approximate the measure of angle A. Now, please listen once again. Every single one of these problems, students, numbers 11 through 18, we're using our calculator. Also, every single one of these, what are we missing? On every single one of these problems, 11 through 18, you're going to notice we're missing an angle. That is when you use your inverse buttons, okay? Tangent inverse, or cosine inverse, or sine inverse. So with that in mind, let's jump into this, okay? I'm missing an angle here, so I'm going to type into my calculator inverse tangent. However your calculator does that. In fact, some of your calculators might have you type in the 0.8 first and then hit tangent inverse. I don't know. Every calculator is different. But inverse tangent of 0.8, if you type that in your calculator and hit enter, you will get 38.7 degrees. Okay? I'm going to go through these pretty quickly. I mean, I want you to get these, but it's the same thing over and over and over. But it's good practice. I want you to do these. You need to do these. Students every year are confused with whether they should use the tangent button or the tangent inverse button. And it's really not that difficult. If you have an angle that you're finding the tangent of, then you use tangent. If you're missing the angle like we are here, then use inverse tangent. Just that simple, okay? Number 12, we're missing the angle, so we're going to type in inverse tangent, however your calculator does that, of 1. If you want to put 1.0, that's fine. It's the same thing as 1. Okay? Hit enter on that, and if you do that correctly and round to 1 decimal place correctly, you will get 45 degrees. Actually, it comes out even. 45 degrees exactly. Okay, moving on to number 13. We're missing an angle, so I'm going to type into my calculator inverse sine, which is what this means. Later on, when you take higher level math, please don't say sine to the -1, okay? That would be embarrassing. It's inverse sine or sine inverse. Either one of those expressions would be acceptable. So, inverse sine of 0.5, okay? And by the way, sometimes I probably say sine to the -1 and just ignore me when I say that. Okay, so sine of 0.5, if you type it in correctly, gives you 30 degrees exactly, okay? 30 degrees. Alright, number 14. We're missing an angle, so we're going to type in negative sine or sine to the -1, or sine inverse, excuse me, I just said it, of 0.45, okay? Hit enter on your calculator, round correctly, and you'll get 26.7. Alright, number 15. We're missing an angle, so whenever you're missing an angle, you use your inverse cosine button. Then you type in this number over here. Basically what you're saying is this, students. What angle, question mark, should I take the cosine of? That gives me this right here, okay? That's what you're looking for. And so the answer is, if you type it in correctly and round correctly, 41.4. And by the way, if you want to check your answer, right here where A is, put 41.4. Now with your calculator, go ahead and type in cosine. Now listen, not inverse cosine, because you have an angle right here, okay? Cosine of 41.4, hit enter, and you're going to get 0.75, which is what you're supposed to get because that's what you have right here, okay? Alright, moving on to number 16. Once again, we're missing an angle, so I'm going to type into my calculator inverse cosine of 0.32. If you enter that correctly and round correctly, That's 71.3 degrees. 71.3 degrees. Okay, number 17. Once again, we're missing an angle, so I'm going to use my tangent inverse and then type in 3.5. So inverse tangent of 3.5, type it in correctly, round correctly, and you'll get 74.1 degrees. Alright? Okay, number 18. We're missing an angle, so we're going to use inverse sine of 0.18. Enter that correctly, round correctly, and you will get 10.4 degrees. 10.4 degrees. Okay, alright. Continuing on, we're doing well, guys. Numbers 19 through 22, the directions say to find the length of the other side that you're missing and the measures of the acute angles. So here we go. Let's get after it. First of all, do you want to know two sides of this triangle? Yes, I do. So I can find this side over here by using Pythagorean's theorem. So very quickly, I'm going to go really fast. I'm not going to try to be neat. Leg squared plus leg squared equals hypotenuse squared. 9 plus 16 equals hypotenuse squared. 25 equals hypotenuse squared. Take the square root of both sides. 5 equals h. Now please, students, don't feel belittled or stupid or dumb if you're not really fast at this. To be honest with you, without hurting your feelings, I hope, you really should know how to do that very quickly by now, okay? But if you don't, remember with video classes, you can back it up and watch it slower, okay? But that is how you would find the missing side. We should be pretty good by now by using Pythagorean's theorem. Now, we're missing two angles. We're going to call this, obviously, angle A and angle B. Students, it does not matter which angle you solve for first. Doesn't matter. Okay, so I'm going to use angle A just because I feel like it, but students, listen to me. You must pick an angle, because when you pick an angle, you then label your sides opposite, adjacent, hypotenuse. And if you choose this angle, then this side's going to be opposite, not this side. No, you'll get the same answer. You'll get the correct answer either way. But I'm just telling you, pick an angle. I'm picking this angle. Go straight across. This is my opposite side. This is my hypotenuse side. This is my adjacent side. Now, students, do I know all three sides? Yes. So does it matter which two sides that I use? No, it doesn't. Pick your favorite one. I don't really have a favorite one. I'm just going to use tangent because I feel like it. So tangent of what angle? What angle did I circle? A. So what angle am I looking for? A. Tangent of angle A equals what? What is the ratio for tangent? Opposite over adjacent. So 4 over 3. Now with my calculator, I'm looking for an angle, correct? So I'm going to type in inverse tangent of 4/3. Now when you type in 4/3, you might want to put parentheses around that 4/3. Every calculator's different, okay? So keep an eye on that. Alright, you're going to get 53 degrees. Well, they said in the directions to round the two decimal places, so I guess we have to do that. So 53.13 degrees. Now, Mr. Earhart, what if I would have used cosine? Okay, I'm not going to do this on every problem, but this problem I will. Okay, use cosine, no big deal. So what angle are we looking for? A. Cosine of A is adjacent over hypotenuse, so 3/5. So, with your calculator, type inverse cosine of 3/5. Be sure and use parentheses if you need to. And look at that. I'm getting the exact same angle, 53.13010235. Guys, I'm telling you, it doesn't matter which trig function you use because you knew all three sides, 3, 4, 5, so it didn't matter. Okay, now to find this last angle right down here is so easy. We take 90 plus 53.13 and we subtract that from 180, okay? And you're going to get 36.87 degrees. 36.87 degrees. Okay, guys? Alright, moving on to number 20. Do we know two sides? Yes. So, let's find the hypotenuse first. Pythagorean's theorem. Leg squared plus leg squared equals hypotenuse squared. That would be 4 plus 9 equals 8 squared, which would be 13 equals 8 squared. Take the square root of both sides. The square root of 13, of course, the direction directions say to round to 2 decimal places, so you will get 3.61. Okay? If you round correctly, the square root of 13 is 3.61. Now, students, we have to find two angles. In the last problem, I found angle A first. Okay? And so in this problem here, I'm going to find angle B first just to be a little different. Now, just like the last problem, do we know all three sides? Yes. So does it matter if you use sine, cosine, or tangent to find angle B? Well, maybe. I mean, not really. But guys, why do you want to use a decimal? Again, make life easier. Why would you want to use a decimal? I'm not going to do that. Plus, it was a rounded decimal, so it's really not exact. So for me, on a test or a quiz, if you used this side to find angle B, no problem. If your answer's off a little bit, no problem. But I'm telling you, for me, I'm using the easiest numbers, and the easiest numbers are non-decimals. So I'm going straight across. This is my opposite side. Here's my right angle. This is my hypotenuse. This is my adjacent. So the two sides that I want to use are my opposite and my adjacent. That's tangent. Tangent is the trig function that has opposite and adjacent. So I'm going to say tangent of angle B, which is the angle I'm looking for, equals opposite over adjacent. Alright? So because I'm missing an angle, I'm going to type into my calculator inverse tangent of 2/3. And if you type that in correctly and round correctly, you will get angle B equals 33.69. Okay? So now, guys, if that's angle B, we can find angle A very quickly. Just add 90 degrees to this, because this angle right here is 90 degrees, and you'll get 123.69, and then subtract that from 180, and you will get 56.31. So angle A is 56.31. Guys, repetitive, but practice makes perfect, guys. Let's keep working on these. Alright, on number 21, we're missing the hypotenuse. Do we know two sides? Yes, we do. So quickly, 3 squared, use Pythagorean's theorem, 3 squared plus 3 squared equals hypotenuse squared. 9 plus 9 equals hypotenuse squared. 18 equals hypotenuse squared. Take the square root of both sides. And the square root of 18 is 4.24. So this side right here is 4. And really, let's learn to do these correctly, guys. Let's learn to use the right symbols. If this is angle C, then the side across from that, we call it little c. That's how all trig books are going to do it. So little c equals 4.24. Okay? Now, we have to find two angles. It does not matter which angle we find first. I'm going to solve for A this time. Okay, now you're welcome to use 4.24. Please feel free to do that, okay? For me, it's a decimal. I don't want to do that. So I'm going to use probably these two sides here. Here's the angle I circle, go straight across. We'll call this opposite. This is my hypotenuse. And so the leftover side is always your adjacent side, okay? So the two sides I want to use are opposite and adjacent. So I'm going to say tangent of angle A equals opposite over adjacent. Alright, so I'm missing an angle. I'm going to type in inverse tangent of 3/4. Inverse tangent of 3/4. And I'm going to get 36.87. So the measure of angle A equals 36.87. Okay, I'm trying to write these properly so you'll learn the right symbolisms. That's exactly how you would write it. Now, if this is the correct angle, which it is, I'm going to add 90 to that because this is 90. So 36.87 plus 90, and then minus 180 is going to give you 53.13. So the measure of angle B has to be 53.13. Okay, there we go. Moving on to number 22. Same thing again. We're missing the hypotenuse. I wish they would have mixed it up a little bit, guys, and had some of the legs missing. I'm really not too pleased with how these four problems are all the same, but I did not write the book, so that's fine. That's just how it is. Alright, continuing on. Now, we're missing the hypotenuse once again, and so, I'm going to find the hypotenuse, or side C, by using Pythagorean's theorem. So leg squared plus leg squared equals hypotenuse squared. 4 plus 36 equals hypotenuse squared. Okay? Obviously 4 plus 36 is 40, and then we're going to take the square root of both sides. So the square root of 40 is going to give you, if you round to two decimal places like you're supposed to, 6.32. 6.32. So side C equals 6.32. Alright. Now again, students, you know all three sides. You're welcome to use this side when you find angle A or B, when you solve for angle A or B, but I'm not going to use it because I don't like decimals. Number one, and number two, it's rounded. It's not an exact number, okay? So, I'm going to solve for B this time. Really doesn't matter which angle you solve for first. I'm going to solve for B. So this is my opposite side. This is my hypotenuse side right here. So the leftover side is your adjacent side, okay? Now, I'm going to use these two sides here because they're whole numbers. So tangent of angle B. And I'm using tangent because the two sides are called what? Opposite and adjacent. You understand that, guys? Okay? So the tangent of B is opposite over adjacent. So 2 over 6. Alright? So I'm going to type into my calculator inverse tangent. And you're welcome to put 1/3, or you can put 2/6. You'll get the same answer. Either way, it doesn't matter. So inverse tangent of 1/3 or 2/6 is going to give you 18.43. Okay? So the measure of angle B rounded to two decimal places is 18.43. Alright, so there we go. And there we go. Alright, now, obviously this angle here is 90 degrees, so I'm going to add 90 degrees plus this angle here, and I'm going to get what? 108.43, I believe. So 108.43 subtracted from 180 is going to give you 71.57. And that would be the measure of angle C, or the measure of angle A. There we go, students. Okay, we're solving right triangles. Pretty cool stuff. Alright, now numbers 23 through 26. You're given one side and one angle. Find the lengths of the sides and the angle. Round your answers to two decimal places. So now, in the last four problems you did, you were given two sides. Now you have two angles to work with. A right angle and a given angle. So in the next four problems, 23, 24, 25, and 26, you're going to find the missing angle very quickly, okay? That'll be simple to do. So this is 90. 90 plus 26 would be 116. So I need 64 degrees here to give me 180, okay? So measure of angle A equals 64 degrees. Now, students, we know one side, don't we? We're missing this side here, which is what? Across from angle A, so we'll call it little a. And we're missing little c. Now, students, it really doesn't matter which angle you circle. Just like I've told you guys, you never use the right angle, okay? When I say it doesn't matter which angle you circle, I'm referring to the acute angles. I don't care which angle you use out of these two right here, but you've got to pick one and then label your sides. Opposite, adjacent, hypotenuse, okay? You have to. I'm going to use this side here, this angle here, just because I feel like, okay, no really set reason. So go straight across. This is my opposite side. Here's my right angle straight across. This is my hypotenuse. And here's my adjacent side. Now, guys, which side do you know? Do you know the hypotenuse? No. Do you know the length of the adjacent side? No. Do you know the length of the opposite side? Yes. So when you look at your trig functions, please listen to me carefully. SOHCAHTOA. You want to use one of the trig functions that has opposite in it. Think about it, guys. If you chose this one, you would have two unknowns. You would have the cosine of 26 degrees. Wait a second, Mr. Earhart. Where 26 degrees come from? We chose that side. You're more than welcome to choose. We chose this angle. You're more than welcome to choose this angle. And your answers will be fine as long as you do your math correctly. Just pick one and go with it, okay? I chose this angle. Cosine of 26 equals opposite. That's A over hypotenuse. That's C. That's two unknowns. How would that work, guys? There's no way that's going to work, okay? There's no way that's going to work. So I've got to choose ratios that have this known side opposite. So I've got this one and this one. Let's start off with sine first, okay? Sine of, this is the angle I circled, so 26 degrees equals opposite, which is 2, over hypotenuse, which is C. Okay? Now, sine of 26 is a number, by the way. Please don't type in inverse sine. You're not looking for an angle. You have an angle, 26 degrees, okay? So sine of 26 degrees is 0.4384 if you round correctly. So 0.4384 equals 2 over C. Now, to get rid of your fraction, you multiply the entire equation by the denominator. The denominator is C. Okay? Now, if the C would have been up here and the 2 would have been down here, then you would multiply both sides by 2. Whatever the denominator is what you multiply the entire equation by. So, 0.4384 times C is 0.4384C. If you multiply the right side by C, your C's would cancel, leaving you with 2. Now, in order to solve for C, divide both sides by 0.4384. And if you do that correctly, you're going to get 4.5623. So 4.56. Alright? So C is 4.56. Now, to find the third side, A, you are more than welcome to use Pythagorean's theorem. I'm not going to because I have this decimal here. Okay? Right here, and I'm just going to leave that alone. I'm not going to mess with that. I can do this faster, I believe. So we already ruled this one out at the beginning. We just used this one. So now let's use this one. Tangent of 26 degrees equals opposite over adjacent, which is little a. I'm going to go pretty faster, okay, guys? Tangent of 26 is 0.4877. So 0.4877 equals 2 over a. What is your denominator? 2 or a? Well, it's a, so we're going to multiply both sides, or the entire equation by a. 0.4877 times a is this. 2 over a times a is just 2. Now divide both sides by 0.4877. And you're going to get 4.100. So I'm going to put 4.10. And there we go. Alright, I really should have listed them out down here. C equals 4.56. Little a equals 4.10. Okay, there we go. Moving on to number 24. Okay, now, real quick, let's find our missing angle here. The measure of angle B has to be 36 degrees, okay? Because 36 plus 54 is 90, and 90 plus 90 is 180. So there, that's taken care of, okay? Now, I don't care which angle we circle. I'm just going to use this one because I feel like it. So here we go. I'm going to go straight across. This is my opposite. Go straight across. This is my hypotenuse. And this leftover side here is my adjacent side, okay? To be honest with you, students, I'm going to do this differently because, not because this works perfectly, I have done nothing wrong, but I really want to use, I'd like to, the last problem, my known side was my opposite side. And if I circle angle B, the same thing's going to happen, and I want to mix it up so you're seeing different types of problems, okay? But if you want to use this and call this opposite over here, go for it, no problem with that, okay? I'm going to use this angle here. So I circle this angle, so this is my opposite side. This is my hypotenuse, and this is my adjacent, okay? Now, let's look at our trig functions. I have sine, cosine, and tangent. SOHCAHTOA. I'm going to quickly copy this so I don't have to keep writing it over and over. Alright, here we go. Now, look guys, do we know the length of the hypotenuse? No. Do we know the length of the opposite side? No. But do we know the length of the adjacent side? Yes. So you want to use trig functions that have adjacent. You don't want to use sine because sine has opposite and hypotenuse, and they're both unknowns. We don't want that. So let's start off with cosine, okay? Cosine of, what angle did I circle? 54 degrees. Equals adjacent 2.5 over my hypotenuse, which is little c, okay, across from angle C. Now the cosine of 54 is obviously a decimal answer, decimal number. So if you type that in your calculator, you get 0.5878, alright? 0.5878 equals 2.5 over C. Now your denominator is C, so multiply both sides by C. And you're left with this, alright? Now, divide both sides by 0.5878, and you're going to get 4.25. So, little c is 4.25. Now, students, please feel free to use Pythagorean's theorem, okay? I'm not going to, but you can. For me, it's faster to cross this off and use tangent very quickly and be done with it. That's me. If you want to put 4.25 right here and then use Pythagorean's theorem, please feel free to do that, okay? I'm going to use tangent. So tangent of the angle that I circled, 54 degrees, equals opposite, which is my unknown, across from angle A, so I'm going to call it little a. You're welcome to call it X or Y or Z, whatever you want to. I'm just trying to do this properly to set a good example in front of you guys. Opposite over adjacent. Adjacent is 2.5. Now remember, the tangent of 54 is a number, so we type that in. Don't use inverse tangent. Its tangent of 54 is 1.3764. So 1.3764 equals A over 2.5. Now, this is a little easier because look guys, my unknown's the numerator. My known side, 2.5, is in the denominator. So I'm going to multiply both sides by the denominator. I'm going to simply multiply both sides by 2.5. So 1.3764 times 2.5 gives me 3.440. And if I multiply this side by 2.5 over 1, these cancel, leaving me with A. So there we go, guys. I now have the length of this side also. Okay, moving on to 25. But I really wish they would give us the length of a hypotenuse. They're just not going to do that. Okay, that's fine. I wish they'd been a little more, had a little more variety in these problems, but that's the way it goes. Alright, number 25. Well, let's quickly find our missing angle. The measure of angle B would have to be 72 degrees, because 72 plus 18 is 90, and 90 plus 90 is 180. Alright, booyah, finished done. Now, it doesn't matter which angle you circle, guys. I'm going to circle this one here. I just feel like it. So this is my opposite side. This is my hypotenuse side. This is my adjacent side, okay? Now, here are my trig functions right here. Now, which side do I know, guys? Well, I know the opposite side right here. So you want to use trig functions that have a known number, okay? You don't want to use this one because your adjacent is unknown and your hypotenuse is unknown. Let's start off with sine, okay? Sine of what angle? Well, I circled this angle, so the sine of 18 degrees equals opposite over hypotenuse. Now hypotenuse is little c across from angle C. Sine of 18 is definitely a decimal number, and if you type that into your calculator, you will get 0.3090 if you round correctly. Now, students, your denominator is c, so we're going to multiply both sides by c. Multiply this side by c over 1, and you get 1.5. Okay, now, let's divide both sides by, hold on guys, I just pushed the wrong button on my calculator. Okay, divide both sides by 0.3090 to see what c equals. Okay, so 1.5 divided by 0.3090 is going to give you 4.85. Alright, now I'm going to change this problem a little bit because I'm getting tired of the same thing over and over. I'm going to go ahead and use Pythagorean's theorem on this one, just to change things up a little bit, okay? So, I know the length of one leg, I know the length of one hypotenuse, so leg squared plus leg squared equals hypotenuse squared. Just break out your calculator and let's use them, okay? 1.5 squared is going to be 2.25. Of course, the leg that you're missing is across from angle B. Here's angle B, so really your adjacent side is called little b. So I'm going to put a little b here, squared, equals, and then 4.85 squared is going to be 23.5225. Alright, now bring this over and make it a negative 2.25. Alright, and you're left with 21.2725. Alright, bring down your b squared. Now we're going to take the square root of both sides. The square root of b, of course, is just b. And the square root of 21.2725 is going to be 4.61. So, I mean, if you like that method better, that's fine. You're welcome to use trig functions also, but there we go. Alright, one more triangle left, then we'll move on to something different, okay? Alright, number 26. Alright, first of all, let's find our missing angle, students, okay? Measure of angle B is 11.31. So the measure of angle A would be what? I'm trying to do this in my head here. It would be 1278.69, I believe. Is that right? Let's see. Yeah, that's right. So, if 78.69 plus 11.31 is 90, and then 90 plus 90 is 180, so there's a measure of angle A, okay? Now, again, I don't care which angle you circle. I'm going to circle B this time, okay? So go across. This is your opposite side. Here's your right angle. This would be your hypotenuse over here, and this would be your adjacent side here, okay? Now, remember, students, you want to use the trig function or the trig ratio that has your known side. And this is not a side right here. This is degrees, the degree symbol. That's for this angle right here, okay? We only know one side, and it's this side here. That's your adjacent side. So do not use sine. Do not use sine, okay? Alright, I'm going to use tangent first. No reason, I just feel like it. So tangent of what angle did I circle? B. So tangent of 11.31 equals opposite, which I don't know. That would be side little b. It's across from angle B. So side little b over adjacent side, which is 5. Alright, now the tangent of 11.31 is going to be a decimal, and you're going to get 0.20000. So I'm just going to put 0.2. Equals b over 5. Now your denominator is 5, so we're going to multiply both sides by 5. If you do that correctly, you're going to get 1. If you multiply b over 5 times 5 over 1, your 5's cancel, leaving you with b. So there we go. So the length of this side over here is 1. So side b is 1. Now guys, look at the two sides that you know. This would definitely be a situation where I would want to use Pythagorean's theorem. guys, I'm back. My computer, every now and then, it's a wonderful little piece of junk here that I have, and it crashes whenever it feels like it. So thankfully, I was able to save the video, but all the stuff I had written was gone, so I had to rewrite this. Anyways, what I was saying to you guys is this. You're missing your third side right here. Now it's across from angle C, so you're missing side C, okay? This would definitely be a situation where I'm going to use Pythagorean's theorem. I have no decimal here, no decimal here. My goodness. Leg squared plus leg squared equals hypotenuse squared. 1 plus 25 equals C squared. 1 plus 25 is 26. Take the square root of 26, and you're going to get 0.5099, so that rounds to 5.10 if you round correctly, which is important to do. There we go. That was pretty fast. Alright, moving on. Okay, guys. So look, when I solve for the length of side C, you could use Pythagorean's theorem, or you could have used, let's see, what was it? Hypotenuse. What angle did we circle? I forget now because the computer crashed, but you could have used your trig functions, or you could have used Pythagorean's theorem. Either way, you'll get the right answer, okay? Alright, moving on. Now 27 through 30 are going to be awesome, challenging problems, okay? And hopefully that's why you took this class. You understand that? So, let's quickly, and believe me, I'm not bragging, but I've done problems like this so much more difficult than this in trigonometry and pre-calculus. I'm just trying to think of the best way to explain this so that you understand it, okay? I know how to do it, but I want to break this down so that you understand it, okay? First of all, step one, read the directions. So you're given the length of one side of a right triangle, and you're given a trig ratio. Find the lengths of the other two sides and the measure of the acute angles. Round your answer to two decimal places, okay? So here we go. First of all, follow my reasoning, please, students. You're given the sine of b is 4/7. Got it? I mean, really, when you look at this, you're like, dude, where do I start? I only know one side. How can I find the other two? I only know one angle. How can I find the other two? Well, you're given a little hit right here, okay? The sine of b is 4/7. They tell you that, okay? The sine of b is what? 4/7. Now, what else do we know about the sine of b? Well, it's opposite over hypotenuse, correct? So now listen to me. When they say the sine of angle B is 4/7, they're basically telling you the opposite side is 4 and the hypotenuse is 7. Isn't that cool? Think about it, guys. You know the sine of B equals opposite over hypotenuse. So now you know two sides, 4/7. But hold it. What angle had you better circle? B, because what angle are we dealing with? B. So circle this. This is your opposite side over here, and look what it is. Booyah, 4. What's it supposed to be? 4. What's the hypotenuse going to be? 7. And now we are so ready to cruise, okay? Let's find this missing side here. We'll call it A, okay? So here we go. We have a leg squared plus a leg squared equals hypotenuse squared. So 16 plus a squared equals 49. Bring the 16 over, make it a negative 16. So a squared equals 33. Now take the square root of both sides. The square root of 33 is 5.74. So just like that, we have the length of side A solved for. Alright, very good. Now, we've got to find some missing angles, okay? Students, please listen to me. You are so more than welcome to use this side right here. I'm not going to because it has a big old decimal number, but you're welcome to. I'm going to use these two sides here, okay? Now I've circled B already. I'm going to go straight. Actually, guys, do you not see how quickly we can find the measure of angle B here? I just thought of this now. Sometimes your old teacher's a little slow. And some of you probably thought of this and already did it. Guys, the sine of B is 4/7, correct? Well, that's what they told us right here. Well, you're missing an angle. How do you find a missing angle? Use your inverse sine of 4/7. That's easy enough. So inverse sine of 4/7 is going to be 34.84, 849. So 34.85 degrees. 34.85 degrees equals the measure of angle B. And now we can find your last angle pretty quickly here. It would have to be what? Let's see. 40, 60, 65.15, I believe, would be the measure of angle A. And no, I think it'd be 55 actually. I believe, yes, 55. So there we go. Okay. Wow, guys. Sometimes I make things a little more difficult than they are. I love the idea that I used because it was my idea. I'm just kidding. I love the idea of saying 4 is opposite and 7 is hypotenuse. That's fine. But I like this idea better here. We could have just taken this at the beginning, typed into our calculator, known the measure of angle B, and then gone from there. So we'll try that on 28, okay? Plus, 28 is not a fraction. Now, trust me, there's a way to find the adjacent and the hypotenuse side doing it the way I showed you, but it'd be a lot easier to do this, guys. Okay, we're missing angle D. Do you see that? Angle D is missing. So when you're missing an angle, type in inverse cosine of this number here. Okay? And if you type that in correctly, you're going to get 51.32 degrees. 51.32 degrees. So the measure of angle D equals 51.32. So let's move this down here. And now, since we know the measure of angle E is 90 and the measure of angle D is 51, we can very quickly find the measure of angle F. Alright? And that's going to give us, what would that be? 50, 60, 30, 38.68, I believe. I think that's correct. Alright, guys, so there we go. So, now we know 2 angles. Now we just find our 2 missing sides, alright? Now, it really doesn't matter which angle that you use here. I'm going to go ahead and write this in here, 38.68. Now, when you go to find your missing sides, I have 2 questions. Do you know 2 sides? No. So you cannot use Pythagorean's theorem. Is it one of my special triangles, 30, 60, 90, or 45, 45, 90? No, it is not. So there's really nothing there I can do either. So I'm going to have to use my trig functions, okay? So with that in mind, I think when the computer crashed, I lost all of this. Let me write this again. I have sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. So, toa. Tangent is opposite over adjacent. Alright, so there's my trig functions. Alright, now, it really doesn't matter students which side you solve for first, but you first of all got to pick an angle. I'm just choosing F because I feel like it. You're welcome to use D. This would be my opposite side over here. This would be my hypotenuse side over here. This would be my adjacent side right here. Okay? Now, students, look, you don't want to use cosine, because cosine is going to be adjacent over hypotenuse, and look, they're both unknowns. You don't want to have an equation with 2 unknowns. However, I do know the length of my opposite side, so I can use these 2 here, okay? So let's start off with sine, okay? I'm going to use sine first. So sine of, I circled angle F, so 38.68 degrees equals opposite over hypotenuse, and hypotenuse would be little e. It's across from angle E. Well, first of all, sine of 38.68 is a decimal, and you're going to get 0.6250. 0.6250 equals 3 over E. Okay? Now we're going to multiply both sides by E. So next we'd have 0.6 e. And if you multiply this side by e, you're left with just 3. Now divide both sides by 0.6250, and you're going to get 4.800, so 4.8. Okay. There we go. Now, to find our last side, I'm going to use Pythagorean's theorem. I don't usually do that, but I'm trying to mix it up so it's not being the same thing over and over. So I know e, my hypotenuse, is 4.8. So I'm going to take my leg, square it, take my other leg, which would be little d, square it, take my hypotenuse and square it, and let's see what we get, okay? 3 squared is 9. 4.8 squared would be 23.04. Bring the 9 over and make it a negative 9, and you're left with d squared equals 14.04. Okay? Take the square root of that, and you're going to get 3.746, 3.75. And there we go. Okay. Alright, moving on to number 29. Alright. Well, once again, we're missing angle H. Okay, we're missing angle H. So students, since we're missing angle H, we're going to type into our calculators inverse cosine of 0.4231. And if you do that correctly, you're going to get 64.96, 64.97, okay? So where are we at here? This is angle H, so the measure of angle H equals 64.97. Alright, that's the measure of angle H. Now, we can quickly find the measure of angle G by saying we have what? 15.03 degrees, I believe that's correct. Or would it be 25? 25. Alright, so the measure of angle G is 25.03. Now students, again, it really doesn't matter which angle you choose. I'm just choosing H because I feel like it. I'm not going to write this number up here, but you can see the measure of angle H is this right here, okay? So I'm choosing H. Again, you can choose G, and you get the exact same answer, okay? Alright, so I go across. This is my opposite side. This is my hypotenuse side, and the leftover side is your adjacent side. Now students, please look, okay? When it comes to your trig functions here, well, first of all, when it comes to your sides, do we know that the length of the opposite side? No. Do we know the length of the adjacent side? No. We know the length of the hypotenuse. So we want to use the trig functions that have hypotenuse. Don't use this one, okay? Alright, having said that, let's use this one first here. So sine of, we circled H. H is 64.97. Sine equals opposite, which is my unknown, and it's across from angle H, so I'm going to call it little h, over my hypotenuse, which is 13, okay? Now this sine of 64.97 is a decimal, and you're going to get 0.9061 if you round correctly. 0.9061 equals h over 13. Now your denominator is 13, so we simply multiply both sides by 13 and we're finished. When you multiply 0.9061 times 13, you get 11.78 if you round correctly. If you multiply the right side by 13, your 13s cancel, leaving you with h. So there's the length of side h, and don't confuse that with hypotenuse, okay? That h does not stand for hypotenuse. That h stands for little h, the side across from angle h. And now you're welcome to use Pythagorean's theorem, or you're welcome to use your other trig function of this problem here. I'm going to use my trig function just because I feel like it. So cosine of angle h, which is 64.97, equals adjacent, which is across from angle G, so little g, over hypotenuse, which is 13. Alright? And by the way, these little g's and little h's, you're more than welcome to use is going to give you 0.4231. And then your denominator is 13. So we're going to multiply both sides by 13 to get rid of my fraction. On the left side, you'll be left with 5.5000. So we're just going to put 5.5. And over here, if you multiply the right side by 13, you're left with g. So we're finished with this problem. Pretty simple. Not too bad, okay? Alright, moving on now to number 31. Alright, we're missing angle K. Tangent of angle K equals 0.6684. So I'm going to very quickly, since I'm missing an angle, type into my calculator inverse tangent of 0.6684. And if you type that in correctly, you're going to get 33.76 degrees. So the measure of angle K equals 33.76. Alright, so there we go. Slide that right here, and let's continue on. Now, I can find the measure of angle L pretty quickly. Let's see, 56.24, I believe. Let's see if that's right. Yes, that is correct. So there's the measure of angle L. Because these two angles here add up to 90, plus 90 is 180, okay? Alright, now we've got to find our missing side, so we're going to have to use our trig functions. I would love to use Pythagorean's theorem, but we only know one side. I would love to use my special triangle shortcuts, but I don't have a special triangle, so there's really nothing I can do here, guys, except use my trig functions. Now, I don't care which angle you circle. I'm going to circle K because I feel like it. Go straight across. This is your opposite. This is your hypotenuse, and this side here is your adjacent side, okay? Now, which side do you know? Do you know the length of the adjacent side? No. Do you know the length of the opposite side? No. The length of the side that you know is the hypotenuse. So make sure you use trig functions over here that have hypotenuse in them. Don't use this one, okay? So here we go. The sine of angle K is the angle I circled. That's 33.76. Equals opposite, which would be across from angle K, so little k, over hypotenuse, which is 9, okay? Now the sine of 33.76 is an actual number, a decimal. The sine of 33.76 is 0.5557, so 0.5557 equals k over 9, okay? Now my denominator is 9. I want to get rid of my fraction, so I'm going to multiply both sides by 9. If I multiply the left side by 9, I get 5.0014, so just put 5. You're welcome to put 5.00 if you want. And then over here, if you multiply this side by 9, you're left with k. So there we go. K equals 5. Now students, listen, this is a perfect problem to use Pythagorean's theorem, because if k equals 5, if this side here equals 5, there's no decimals. Man, I can very quickly find this missing leg over here, okay? And by the way, the side you're missing is little l, okay? I'm going to use a little cursive L, I guess. This is big L, so cursive L. So I have my little leg squared plus my other leg squared equals my hypotenuse squared. I can do this pretty quickly. 5 times 5 is 25. 9 times 9 is 81. Bring the 25 over and make it a negative 25. And you're left with L squared equals 56. And the square root of 56 would be 7.48. 7.48 equals little l, okay? So there we go, guys. Not too difficult, really, okay? Just redundancy, repetitive, which is what you guys need. It's good practice, okay? Alright, moving on to 31. Find the length of the altitude of the tetrahedron, okay? Now look, notice if you look in your books, I did not give you the picture of the molecular structure of methane. Okay, there's no need for that. It's good. It's a good problem. Don't misunderstand me. But that drawing can be confusing. I'm using the drawing to the left of it, which really gets rid of all the H's and the C's and those circles and all that stuff. Just gives you a basic tetrahedron shape, okay? So they want us to find the height of the length of the tetrahedron. So here it is right here. There's the height. Okay, well guys, see that right angle right there? I've got a right triangle right here. Okay. There's my right triangle right there. So I'm going to pull this picture out of the way. And if you'll look, this length here is 1 from this right here. And this length here is square root of 3 from this here. So guys, this might be the easiest problem we've done the whole class period. I mean, Pythagorean's theorem, we'll call this x, okay? I guess technically because there's a b here, I should call this little b, but like I've said, you don't have to do that. So we're going to use the x on this one. So one leg is x. The other leg is 1. The hypotenuse is square root of 3. When you square a 1, you get a 1. When you square a square root, you get the number on the inside, which is 3. Bring the 1 over and make it a negative 1. So now you're left with the x squared equals 3 minus 1 is 2. Take the square root of both sides, and you get square root of 2. Okay, now, the whole class period, we've been typing these in, and getting decimals for some reason on this problem. They left it square root of 2. I really don't care. Students, you're welcome to put square root of 2, or you're welcome to put 1.41, whatever works for you, okay? Alright, moving on to 32. Find the measure of angle DAB, okay? DAB. So here it is. Here's D. Go up to A, and then down to B. Well, guys, once again, we're dealing with the same right triangle. Okay, so I'm going to pull this figure out of the way here, and I'm going to label this D, A, B. This is a length of 1. This is square root of 3. Now, students, I have some questions for you. First of all, do I know any of my acute angles? No. So there's no way I can quickly add these up and subtract from 180, correct? Correct, okay. So I'm looking for this angle here. So I'm going to circle it. That gives me some structure, right? What would I call this side over here? Opposite. What would I call this side here? Hypotenuse. What would I call this side over here? I don't care. Okay, just kidding, but I really don't care because now that I have these two sides here, I can find this angle very quickly. Do you see what I'm saying? I'm going to call this angle A, obviously, for obvious reasons. And so, I don't need this side. I've got two known sides. What are these two known sides called? Hypotenuse and opposite. Really? Well, which trig function uses opposite and hypotenuse? Isn't it sine? Didn't mean to do that. That's okay. The secret's out. Now you know what the answer is, alright? So, look. Sine uses opposite and hypotenuse. So use sine, guys. Sine of what angle? Well, what angle you're looking for? This angle here, angle DAB, or angle A. So the sine of A equals what? Opposite over hypotenuse. Type that into your calculator, guys. You're looking for an angle, so hit inverse sine equals. Now, if you don't know how to put this in, or not equals, sorry, sine, inverse sine, if you don't know how to type this to your calculator, then maybe off to the side, make this a decimal. Somehow take 1 divided by square root of 3, hit enter, and this whole expression here equals 0.577, 0.577, 3502, etc. Okay, and put that in for me. I'm just going to put 1 divided by square root of 3. Okay, so you're looking for an angle. Be sure and hit second sine or inverse sine, and then type in either this number or this decimal number, and you're going to get 35.26. So there we go. 35.26 is the correct answer, which is what we see here. Alright, and last but definitely not least, DBA. Now guys, look, we know this is what here? 90. Did we not just, okay, let me go ahead and get a picture so you all see it. Alright, here's my right triangle again for the third time. Alright, slide this over. Alright, D, A, B, right angle, 1, square root of 3. Did we not just find the length of the measure of angle A? Sure know this angle right here is 35.26. Then when we find the measure of angle DBA, this angle here, well guys, just add up and subtract from 190. So it would be 54 point, let's see, 74 I believe. Let's see. Yes, that's correct. So 54.74 degrees, because this plus this is 90, plus 90 is 180. So really, not a lot of work to do on that one. Okay, guys. All right. I hope this homework help video has been a help to you. Maybe you viewed it more as a curse. I don't know, but I hope it's been a help to you. If you have any questions, don't hesitate